Hey, hello there, welcome back. So it is the next day, and it seems that I needed some rest. Today, with fresher eyes, I can see my refactor solution from yesterday and notice a couple of things that I would probably like to improve, but I couldn't do yesterday because I think by the end I was pretty sleepy or tired, tired from seeing this code. So this is a continuation of the previous video, and that's basically two things that I would like to try. They should be simple, I think, but I don't know, I usually take more time to do things than I would like to. So let's see. The first thing that I would like to try is what I didn't do yesterday and I had an idea of doing, which is to extract the main logic of this solution, which is pretty long and a bit involved, and I think it could be simplified because we are basically doing two things at once. And we could extract a function to call it twice and have it hopefully be simpler. So what all of this code is doing, so the first part of this code is just parsing the program and splitting that program into the blocks that we have, blocks consisting of a single input and the rest of the instructions. So this is what this does. This is okay, but all the rest, all of this code up to here, I guess, is just calculating a model number. That's what it's doing. It's actually, and what I find is convoluted, is that it's actually computing two model numbers, the minimum and the maximum one. And we are doing all of that in the same main loop that iterates over each block. And so we have like two accumulator variables, max inputs and min inputs. And then we have two different loops here nested that are for the minimum and maximum inputs, and the only thing that changes between these two is when picking between two inputs for the same z value. So this is what this code does here. Basically it's this if condition, which now I realize it could probably be converting into a minimum or maximum call. But yeah, this one picks the maximum, like if the current inputs are greater than what's stored, we replace it, and in this, all of this is the same, but it only changes this condition. If it's less than, then we pick it. So I think we can basically extract this whole thing into a function and make it vary in that decision, basically. So let's try to do that first. I think it's gonna be from this to up to here probably. Let's just yank it and call this thing, because this thing is basically, as I said, is finding a model number. So let's just call it find model number. And it's gonna return, I guess a string could be, because that's what we end up calculating, just a string. So maybe before doing this, let me undo a little bit. I want to save the current output. So if I run this now, I guess I get these two outputs. So let's run this quietly and dump this into day 24 answers file. So now I have this file. I said car, I mean cat. Just so we know which are the correct answers and don't have to check the my submission. So let's redo what we were doing. Okay, we have all of this. I'm going to remove all the code that has to do, like only leave the max inputs branches and remove all the minimum inputs things. So here we don't need all of this by min inputs by and this goodbye, and then we are gonna return this join string. Okay, this thing needs the blocks, so let's pass it to it, and we're going to print max model number and min model number. I guess we can have variables for that. Let's max model number. It's gonna be find the model number. We're gonna pass these blocks. Okay. And I want the type of these blocks, which is this. I guess we can change it to a slice. Slice of vectors is maybe not too nice, but okay. Okay, it's not complaining. Yeah, but we haven't parameterized the this condition there. So now we're going to be finding both the maximum numbers basically. So let's run this thing again. And yeah, we get two numbers, but they are both equal because, well, we need to also have a condition for this. So I guess one possibility would be passing a boolean. Oh, by the way, these max things shouldn't be called max inside of here. So this should just be maybe inputs, or I would say inputs by sed, which sed is like the internal variable. And this should be new inputs by sed. Okay. And do we have any more references of max here? Okay. Let's call this inputs. And that's fine. Okay. And now, yes, we could pass a boolean, I guess, and like to tell either pick the maximum or the minimum. But I think it would be better to pass a function that picks between two given inputs, and then we can pass whatever function we want there. So this would be a pick inputs. Pick inputs function, which, well, here we could have a parameterized type for functions, or we could have a dynamic dispatch. So like it would be a function from, well, what are the input types? Input types, I'm using vectors, so it would be one input would be a vector of inputs, the other input would be another vector of inputs, and the result of this would be picking either one. Right, something like that. And we would use this pick inputs here. So we would say something like v equals pick inputs between what v was already and inputs, and we make it non-conditional. So here what do we have here? I wonder if I should be using references there. Let's see the error. Oof, that's a long error. We have different errors. We also have errors in the calling. So here we need to pick between two inputs. And I guess we can call it A and B. And we are going to pick the maximum. So we can say, hey, give me the maximum between A and B. And basically, I want to do the same thing below, but pick the minimum. And this doesn't like. It expected a dynamic thing. Does this need to be a dynamic reference? Maybe it does. And how do we do dynamic dispatch on closures? Can I take the reference to this? Okay, that works. Although I will convert it to a parameterized type, but I just want it working first. And this other error, yeah, because it's a reference, and if we dereference this, we can probably not. Yeah, we cannot copy it just like that. We are moving out of a mutable reference. So what do we make a copy? Oops. That doesn't seem very right. These things about thinking of ownership. We want to pick between the two. And I want, what is it that I want? I want to return like ownership of it. You know what? I will make a copy. Because this is something that I would like to change later. Like I don't want to use, like spoiler alert, I don't want to use these vectors of numbers as inputs. But now we have another problem. And it is that type annotations needed here. Oh, okay. I find it weird that sometimes like the Rust analyzer thing knows more about like the inferred types of things than the actual compiler does. So I don't know how that works. But anyway, if we run now, we get two answers. And if we run it quietly and we diff between this thing and I guess the day 24 answers, we get no difference. So that's good. That's very good. Okay, but we are doing this with dynamic dispatch on these functions, and here we are saying, okay, this pick inputs takes two inputs and returns the one that it chooses, and one of these chooses maximum, the other one chooses minimum. So okay, it works. and it's going to be dynamically dispatched. But this is one of the nice things about Rust. Traits can be used for dynamic dispatch, but they can also be used for bounding. How is it called? Like type bounds on generic types. So we can yank this and say, okay, pit inputs is going to be a p type, and this is going to be parameterized on a p type, which is bound by this. Or I guess we can also say something where p is this. I actually don't remember where the where clause goes. I think it's probably here. Okay, yes. Yeah, I think that's probably better. And now we don't need to pass them as references. I think it should work. Yes, and now it's not, well, I'm running the thing now again, but there was no difference. We're still getting the correct answers. So this also works, and I think I would prefer this and instead of the dynamic dispatch for this code. So, okay, we have extracted this successfully. Maybe one thing that we could try, yeah, this is also pretty readable. Like the max model number is find the model number with these blocks and pick the maximum. I do wonder, this maximum belongs to CMP module. So can we say something like CMP max if we import this? Yes. All right, that's cool. So we can just pass the functions like this, and this should work the same, right? Yes, it does. I don't know if this is like maybe too clever, but I kind of like this sort of eta reduction. Instead of using a closure, it's like that only calls one function. It's like use that function and that's it. Okay. So now I think this refactor is quite good, because we have, like before, we have a bunch of code that did repeated things, like two repeated loops. All of this other loop was unnecessary, and now we gave all of that a better name called find model number. So we now, properly talk about model numbers, and yeah, we are parameterizing the logic of the two different model numbers that we want. In one case we want the maximum, and in another case we want the minimum. And yeah, this makes a lot of sense, at least to me. So let's commit this. Let's add this and commit. Extract main model number logic into a separate function, and call this function twice, once for the maximum model number and once for the minimum. Okay, a bit verbose, but that is fun. All right, so successful refactor. The other thing that I wanted to do, I'm not entirely sure about this, but I think it would be a nice simplification. So these model numbers, we are talking about, yeah, model numbers, but we are returning a string instead of actually a number. And inside of this code, we are treating like we are iterating over different inputs for this program that we are executing, and all of these inputs is weird. Like W's are the inputs, and we're going like from 1 to 9, but we are accumulating those things into vectors. So this is like the inputs is a vector of numbers, and we are accumulating these single-digit numbers. And then once we have all the inputs, we like convert it to a string and join them, and that creates the string. But if inputs are numbers, like their digits are 1 to 10, like single-digit numbers, and the result of all of this is a model number, shouldn't we be using just numbers instead of strings or vectors of single digits? And that's what I want to try. So yeah, instead of a string, I guess these are all positive numbers, so I don't think I need a signed integer, so I'm thinking of using just unsigned 64-bit numbers. Yeah, but maybe the mix of unsigned, because in other places I'm using signed integers for, because these things, the operations inside can be negative, so maybe signed integers is okay. Because otherwise we are probably going to be converting from signed to unsigned to do arithmetic. So now also the picker function will just pick between two numbers, which is great. And in fact, given this simplification, I wonder if we can put the bound in here and still be in one line. Yeah, great. Although, yeah, I think the where clause is nicer. Like it separates the condition. Yeah, I don't know, I think it's all right. And now, inputs by Z. Instead of starting with an empty vector here, I think I could start with the number 0. Yeah, so I want to be accumulating, instead of accumulating into a vector, I want to accumulate into just a number, a base 10 number. And same thing here. You can probably, I think you will need to infer, but, or I want this thing to be inferred, but let's see if we can manage that. So we go from 1 to 9. Running the ALU program should be the same. This condition should be the same. Oh, this condition I think can also be simplified, but let's do that later. Previous inputs is now just, yeah, a number. That's great. And now we don't need to clone this thing. It's just a number, but I want a copy of it, not just a reference. And actually, I can probably dereference these things. Expect tuple. Why cannot dereference like this? Maybe. Okay, doesn't matter. So how do we push the new input, like single-digit W, into this? Well, we can multiply these inputs by 10. So it's basically going to be inputs times 10. So we kind of shift. This is not binary, but base 10. Shift to the right, to the left, sorry, and add the W. And actually, we can do that just here. We don't need to make it a mutable thing. That's awesome. So now, if we had, this is the logic of inserting things into this hash. If we had a previous value, we're going to pick the inputs and we're going to pass the previous one and the new one. And the previous one here is a mutable reference, so we can dereference this. And that's it. I think that's it. And for some reason, now this thing can be inferred. That's great. Yeah, awesome. And now we have the inputs. It's just a reference. And we don't need to convert to string or anything. It's just, this is what we want. This is the return value that we want. I think that's it. So this made code much simpler. Let's see if it still runs the same. And it seems it does. If we do the diff, yeah, still the same numbers. So this is an awesome simplification, but because it makes not only the code is simpler to read and to reason about, like these are numbers, like why don't we use numbers instead of vectors? But it also should be like, you know, much computer friendly, like friendly for the computer to execute instead of allocating new memory for these vectors. It's just dealing with 64-bit numbers. So that's awesome. This is a very, very awesome refactor. So yep, I also want this. Let's commit. Use plain integers for inputs instead of vectors of single digit numbers. Okay. That's great. And I think this condition, like, I need to apply some Carnot simplification here. So this was the condition of, okay, when we can reduce this Z and the Z was reduced, we do this. Or we can also do this when the Z cannot be reduced. So can we convert this into like one single expression? So I think we can say, hey, if we cannot reduce Z, do this. Or if we can reduce it and it was reduced, then do that also in that case. I think that should be, I don't want to do a truth table to analyze if this is the same. I will just, in fact, run with the diff, and yeah, it's giving me the same numbers, so I will trust that this is the same condition as before. It made sense in my head when I thought about it, but yeah, let's trust the results. So yeah, that's also a nice change. Say simplify boolean condition. And yeah, that's it. That is some nice refactor on this code. So let's do a recap of what we did. We extracted this main function, like all the mess in this run function. We extracted it to a nicely called find model number function where we just pass the the program blocks, and also a comparison function to pick between two different inputs. Then we also changed the internal data structures, and I wonder if this can also now infer this type. Yeah, it seems it can. So maybe we can use plain integers for. I guess we can do a fixup on this commit. So this is a Git trick that I like to do. Let's add the source and let's do git commit fixup over this, and then hit. I have an alias which is rebase interactive something squash or whatever, but I just call it git re, and rebase from this commit, from the previous of this commit. So this will allow me to pick these two things, and the fixup is enqueued directly after the one commit that we are fixing up. So we should be fixing this, and yeah, this is the rebase that I want to do, and it did the rebase. So now we can run again, and like the history has, well, this simplification of the condition, and now this commit also includes this change that I just did. Okay, so that's something that a little trick that I like to do. Okay, I think that's it for now. Yes, finally it is the the end, I think, unless I catch something up that I spot something up that I want to change. But now I'm pretty happy about the shape of this code, and I just needed some rest from yesterday to see it with like fresher eyes. So if you have been following with this mess of a solution to the M-word puzzle of codes, thank you very much, and I hope you, I don't know, enjoyed it or learned something new. And if not, well, that's it. These videos are very, very long. I doubt that anyone would watch them entirely. But anyway, that's it for today. See you later. Bye bye.